Okay, so this is your tracker file, right?
Yes.
I'll move this here. Okay, so do you have a calibration stick here, and you're saying that's 1 meter? Okay, that's good. I'm gonna click here so I don't have to look at your calibration stick. Now I'm gonna put my grid, well, I didn't mean that. I'm gonna put my grid here. So this is I'm defining my X, Y, okay? My positions in the horizontal, my positions in the vertical. I won't use Y, I'll just use my X for this. What else? Let's create point mass, and graphs will show up on the right. Okay, and then let's see if we can track our object. Well, actually, let's see if we can use tracker to track our object. I hit Shift Control, and this looks like it's pretty unique, and that's where I put my grid. So I'll have your object starting at 0 meters, right? And then I'll just hit search, and I'll move this out of the way, and let's see how it does. We're getting our data. It looks pretty good. Oh, your object hasn't moved yet? Okay. Okay, tracker got confused there. You see how I know it got confused?
Yeah.
So this isn't gonna work. So here's what you do when it doesn't work. You hit close, you hit mass A. This is what I do. This might not be the best way of doing it, but that's how I do it. And I just start over. And I say, well, that didn't work. I better choose, I'm not gonna move my grid around, my grid's fine. I'm gonna choose a different spot. Maybe I'll choose the front. Let's try that. So I'll create a point mass again. There we go. These graphs will show up on the right. So I literally throw out the whole thing. And then I go here. There are other ways of doing it, by the way, but that's just the way I like doing this. Okay, so I'm gonna try the front of the car, see if that works any better. It's working. And I'm just watching, see how well these match, and I'm making sure nothing horrible happens like it did before and it is again. You know what I think is confusing, Tracker? Your car is so awesome. It did a wheelie. Did you guys see that? Her car did a wheelie. That is so cool. Poor Tracker's getting confused though. So maybe if I choose create point mass. Okay, so I'm gonna choose here now. And eventually, it's gonna work. Because I don't think I think there's something unique about, see how it's matching? As long as there are no other pixels that are in that exact pattern. Yes! We've got it! Cool? It worked. We're good now. Hit close. Rad! And we have awesome data. Okay, go to table. Get rid of Y. Who cares about Y? Close this. Now this is what we needed from Tracker right there. I did Apple A, Apple C. Now I can open Logger Pro, if I can find it. There it is. So I'll open Logger Pro, and I'll just paste this in the Logger Pro. And I should be saving your work right away. Apple V. So I just pasted it there. This was time. Oh, that's great. That's not what I wanted. I just ruined it. Good maneuver. Let's try that. Apple V again. There, I just fixed it. Now I'll double click up there. So time, T, seconds. Okay. And this was position. Whoops. X, meters. So you guys got a little bit of time? Because we can finish it. This will come out really nice. Okay. So I already know it's going to come out great. Now, if I move this guy over, I make this guy larger, then I can make a third column for my velocities. Data, new calculated column, I'll call it velocity. Really, I mean instantaneous velocity. Velocity, V, meters per second. Are you guys in calculus?
Yeah.
I'm going to use derivative. All I'm saying, I'm saying find the slope of my position time graph. What's the slope of position time?
Velocity.
That's all I'm doing. Cool?
What the?
And the reason I'm using calculus is because this is a curve. And now I have a column for velocity. And so now I'm going to make another graph. Control, or Apple C, Apple V. So now I have two graphs. Apple R rearranges everything again, makes it look pretty. Then my velocity graph is here. And I can totally see what's going on now. Let's make this like 2. So I click up there, make that 2. Click up here, make it like, I don't know, 3 or something. Well, that didn't work. 3 maybe. Now I'm looking here and I'm saying this is the speeding up. Yeah? So I'm going to put best fit line there. And I'm thinking this part here is all the slowing down.
I think it's just like it's already made.
Told you we get a really nice graph. Right? And then I can do better even, especially in an honors class like you guys are. Okay? I can take this stuff. Now, if you recall your general equations for constant acceleration, you have v equals at plus v naught. Okay, that's what this is. That's this equation right here. Well, equation for position is 1/2 at squared plus v naught t plus x naught. Right? So you can actually see how well your data fits that model. So analyze model. And choose quadratic. Quadratic is the form of 1/2 at squared plus v naught t plus x naught. I just need to figure out what my a is. Oh, we're doing a screencast right now. My a is 2.53. Right? What's half of that?
1. No.
1.2, 1.25? 1.26? 1.265. Yeah?
Yeah.
What's my initial velocity? It looks like it's...
Negative 3.88.
Okay, so I'm going to write negative 3.9. Okay? And watch, this part's beautiful. As we adjust this, we should see if our... Oh my gosh, make this a smaller interval. Make this 0.01 for our fine adjustments. Okay? Look at how well this model fits our data. It's really nice. For real life, this is incredible. And then we have a slowing down period. That's incredible how close we fit that. That's really good. So our equations are working beautifully at representing the motion of this mousetrap car. That's really cool. Now let's try this slowing down period. Analyze model. I'll move this over so you can actually see. What's half of that number? That's our acceleration during slowing down. What's half of it? It's got to be a negative. Half of 18 would be 9. So this is 0.85?
Yeah.
Negative 0.85. And then our initial velocity is 5.4. So I'm using the information from the lower graph. And now I'm going to have to tediously move this around. I'm not even sure which way to go, but I think I go this way. Yeah. Because my intercept to fit that curve is going to be very negative. Right? Oh my god. That's really nice. So your data, people are going to be jealous of your data because it's really nice. Look at that. That's really cool. This would be good data to use if you didn't have any data. Your mousetrap car didn't get to work. This would be great to use because we have a beautiful speeding up and a beautiful slowing down that fits perfect. And just explaining these numbers and what they mean, that's the minimum requirement. Sound good? You could always go a little bit deeper into the physics and it wouldn't hurt. But I'm not going to penalize you if you don't. Just talk about the accelerations and do a good job. the acceleration when you're speeding up, it looks like your car speeds up 2.5 meters per second faster each second. And then in the second period of time, it's going to slow down by about 1.7 meters per second every second.
Yeah.
And then these times are going to be useful if you're going to go for the 2 points for the VPython. You can use the times from Logger Pro in conjunction with those accelerations, and you should be able to get VPython to exactly model the motion of your car as well. And it'll look exactly like the video. And all it's based on is the equations. So it's a different way of modeling. Here we've modeled with the equations and graphs that you can see visually, but you can also model with code in VPython. Pretty cool.